What's up, you freaking geniuses? So in this video, I'm going to teach you how to solve radical equations, all right? So let's start with this one right here. So we have the square root of 4x is equal to 6. Okay, so in order to get rid of radical symbols or square root symbols, you need to just square it, okay? But again, whatever you do to one side of an equation, you have to do to the other, right? So we have to square this side also, okay? So then on this side, this radical symbol, the square root, right, and this squared exponent are going to cancel out. So then we're just going to be left with 4x on this side. Okay, so we're just left with 4x, and that's going to be equal to 6 squared, which is equal to 36, right? Now, in order to solve for x, we just need to get rid of the 4. So we're going to divide by 4 on both sides. Okay, so then over here, these 4's cancel out. So then we're just left with x is equal to 36 divided by 4, which is equal to 9. Right, so that'd be your answer right there. X is equal to 9. Okay, so here we have the square root of 2x minus 1, right? That whole thing is under this radical, and that's equal to 7. Okay, so again, in order to get rid of this radical symbol, the square root symbol, you just need to square it, okay? And whatever you do to one side of an equation, you do to the other, right? So again, we have to square this side also. All right, so then on this side, this radical symbol and this squared exponent are going to cancel each other out. So then on this side, all we're going to be left with is 2x minus 1, right? 2x minus 1. And that's going to be equal to 7 squared, which is equal to 49, right? All right, cool. So now this turned into just a straight linear equation, right? So we're just trying to solve for x right here. So the first thing we're going to do is get rid of this minus 1 by adding 1. And what we do to one side, we do to the other, right? So then on this side, minus 1 plus 1, those cancel out. And we're just left with 2x is equal to, and on this side, 49 plus 1 is equal to 50. Okay, so again, to solve for x right here, just get rid of the 2, so we need to divide by 2, right? And what we do to one side, we do to the other, right? So then on this side, these 2's cancel out, so then we're just left with x is equal to 50 divided by 2, which is 25. Boom. Okay, so here we have the square root of r plus 4 plus 2 is equal to r. Okay, so again, what I want to do here is get rid of this 2, right? So we can just kind of isolate this radical by itself. Okay, so I'm going to subtract 2. And what we do to one side, we do to the other, right? So then here, these 2's cancel out. So then on this side, we're just left with the square root of r plus 4. And that's going to be equal to this side right here, r minus 2, right? r minus 2. Okay, so now that we just have this radical by itself, now we can square it. Okay, so we're going to take this whole thing, and to get rid of the square root, we're going to square it. And again, what we do to one side of an equation, we do to the other, right? So we have to square this whole thing also. Whoa, that's a big 2. That's what she said? No, that doesn't work. Okay, so we got a 2 right there. So then on this side of the equation, this square root and this squared exponent cancel out, all right? So then we're just left with r plus 4 right here. So r plus 4 is equal to r minus 2 squared. So we can write that out as r minus 2 times r minus 2. All right, so then to just clean this side up, we have to FOIL it, right? First, outer, inner, last, right? So we're going to go first, so r times r, that's equal to r squared. Then we'll go outer, so r times negative 2 is equal to negative 2r. Then we'll go inner, so negative 2 times r is equal to, again, negative 2r. And then we'll go last, so negative 2 times negative 2 is equal to positive 4, right? So then that's equal to this side over here, right? r plus 4. Okay, and now we can simplify something really quick. So on this side, we still have r plus 4, and over here, we can combine like terms. So we'll have r squared, and then here in the middle, we have negative 2r minus 2r, which is equal to negative 4r, right? And then we have plus 4 at the end right there. Okay, now the last thing we're going to do here is, once again, combine like terms. Okay, so here we have just a number, right? And here we have just a number, so let's group those together. So we'll subtract 4 from this side and move it over here. So subtract 4 from this side. So then on this side, these cancel out. And on this side, they also ended up canceling out. Okay, and then the other thing we can do is move this r. So we'll subtract r from this side, and we'll subtract an r from this side, okay? So then here, they cancel out, right? So then on this side of the equation, we're basically just left with a big fat 0, and it's equal to this side over here, so r squared. And then here we have negative 4r minus r, and that's equal to negative 5r, right? Negative 5r. Okay, and now I'm just going to move my equals 0 part to this side over here because I think it's a little cleaner that way. Okay, so here we're just left with r squared minus 5r is equal to 0, right? Now, in order to solve for r over here, we can actually factor this. Okay, so we're going to factor out an r from both of these terms, just a single r. So then inside the parentheses, we're just going to be left with r minus 5, okay? And again, that's equal to 0. Okay, now to solve for r over here, this r out here, r would have to be equal to 0, right? And for this r on the inside, r would have to be equal to positive 5. Okay, so then these are our two answers, right? R equals 0 and r is equal to 5. Now, it's important to always check your answers to see if they're right. And the way that you do that is by simply plugging it into the original equation, which was this one right here. Okay, so the square root of r plus 4 plus 2 is equal to r, right? So we're going to check both of our answers right here, starting with this one right here. R is equal to 0. So we're going to plug in a 0 for r right there. Okay, so I'll just rewrite it on this side over here. So we're going to have the square root of 0 plus 4 plus 2 is equal to r, which again we're saying is 0, right? So then here we have the square root of 4 plus 2 is equal to 0. So the square root of 4 is just equal to 2, so we get 2 plus 2 is equal to 0? No, that's not right, right? So whenever we plug in 0 for r right here, it gave us an unbalanced equation, right? Because 2 plus 2 obviously does not equal 0. Okay, so r equals 0 is what we call an extraneous solution. Essentially, it's not a solution, all right? So now we just have to check our other solution right here. R is equal to 5. Okay, so again, plugging it back into the original equation, we're going to get the square root of 5 plus 4 plus 2 is equal to 5, right? So then inside the parentheses, 5 plus 4, that's equal to 9. And then plus 2 is equal to 5. So then the square root of 9, that's equal to 3. So we get 3 plus 2 is equal to 5. Is that a true statement? It sure is, right? So that means r is equal to 5 is a solution to the equation. All right, before we start, I have a secret for you. We're going to solve the shit out of this one. All right, so here we have the square root of m plus 1 is equal to the square root of m plus 9. All right, so as you can see, we have a square root on both sides of the equal sign. That sucks. But we're going to solve it the exact same way, okay? We're just going to end up squaring both sides, right? So we have to square this whole side, okay? Not just the radical. You have to do the whole side. And we have to square this whole side also. Okay, so on this side, we're going to have the square root of m plus 1 times the square root of m plus 1, okay, right? And that's going to be equal to this whole thing squared, right? So in this case, this is kind of nice because the radical and this exponent are going to cancel each other out, so we're just going to be left with m plus 9 on this side, m plus 9. Okay, now we have to FOIL this again. What a shame. All right, so we're going to go first. So square root of m times the square root of m is just equal to m. So that was first. We're going to go outer. So square root of m times 1 is equal to just the square root of m. Then we're going to go inner. So 1 times the square root of m, again, is just the square root of m. And then we're going to go last. So 1 times 1 is equal to 1. So plus 1. So that's equal to m plus 9. All right. So again, I want to simplify some things here. So on this left side, we're going to have m plus, and then here we have the square root of m plus the square root of m, and that's equal to 2 times the square root of m, right? It's like saying 5 plus 5 is equal to 2 times 5. Okay, so that's why we can write it like that. And then we have plus 1 is equal to m plus 9. Okay, so as you can see, we still have this radical right here, so we want to try and isolate it, okay? So let's get rid of this m and let's get rid of this minus 1. So we're going to subtract m from this side, so that means we have to subtract m from this side. And here we're going to subtract 1, so here we're also going to subtract 1, right? So then here, these m's cancel out, and here these 1's cancel out, right? So then on this side, we're just left with 2 root m. 2 root m, and that's equal to, right here, m minus m. Well, those killed each other also, so that was nice. So here on this side, all we're left with is 9 minus 1, which is equal to 8, right? So in order to solve for the radical right here, we need to get rid of the 2. Okay, so we're going to do that by dividing by 2 on both sides. So then on this side, these 2's cancel out. So we're just left with the square root of m is equal to 8 divided by 2, which is equal to 4. Okay, now in order to get rid of the square root symbol, or the radical symbol, again, all you have to do is square it, and what we do to one side, we do to the other, right? So then on this side, the radical and the squared exponent cancel out, so then we're just left with m on this side. So m is equal to 4 squared, which is equal to 16, all right? And boys and girls, please don't forget to check your answer. So just plug in 16 back into the original equation, but you will get a balanced equation when you plug in 16 for the m's right there. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.